High-quality 3D shape generation and manipulation are challenging tasks. Previous works on 3D manipulation are time-consuming and do not allow interactive use. Moreover, there is a large gap between the advancements in 2D and 3D vision. In our work, we aim to address these issues and present a fast and efficient framework for text and image-guided 3D face generation and manipulation. To do this, we use TBGAN as our base generative model, which generates geometry images. We leverage this image-like 3D geometry format and propose a framework that leverages clip and differentiable rendering to manipulate meshes with text and image prompts in only 5 minutes. A geometry image is an image-like format that is created by projecting the target mesh onto a primitive 3D shape and unfolding it to create an n-by-n image. This process creates a bidirectional mapping between the pixel coordinates and 3D coordinates of the shape. In our work, we operate within the latent space of TBGAN. Given a text or image prompt, our goal is to find an optimal latent vector that yields a mesh with the target attributes. Let's go over this process step by step. TBGAN receives a random latent vector and the one-hot encoded expression vector as input, and generates geometry images coupled with corresponding texture and normals maps. The geometry images can be projected on the 3D space with a simple matrix multiplication, and then fed into a differentiable render module to generate multiple views of the mesh. In our work, we render 3 views of each mesh. Once again, our goal is to find an optimized latent vector that generates a face mesh with the desired attributes. For iterative optimization, we use a composite loss that consists of a clip-based loss to enhance the target attributes, an arc face-based identity loss, and an L2 loss to prevent artifact generation. At each iteration, we use clip and arc face to compute our clip and identity loss terms along with the L2 loss, and backpropagate this composite loss through TBGAN. We evaluate our method extensively and compare it to a baseline PCA-based manipulation method as well as conditional generation with TBGAN. For all experiments, we use a fixed number of 100 optimization steps. Our results show that we can manipulate the original meshes effectively with various text prompts such as old, child, big eyes, thick eyebrows, or makeup, as well as more complex prompts that require gender and race changes. Furthermore, our method allows fine-grained control over the manipulation strength and can handle sequential manipulations. We also show how the identity loss weight can be adjusted to perform successful image-guided manipulations. We further show the effectiveness and identity-preserving success of our method by comparing our text-guided expression manipulations with expression conditional generation with TBGAN. Similarly, we include comparisons with the PCA-based method. Our human evaluation surveys with 25 participants confirmed that our method performs more accurate and identity-preserving manipulations. In conclusion, we introduced a fast and efficient framework to manipulate 3D face avatars with text and image inputs by leveraging a compact 3D representation format and powerful image representation models. Thank you.